evening, good afternoon, good morning. Please, may I have the next slide?
Hold on a second. Now we're recording. Okay. Thank you.
So today I'm going to speak a little bit about domain names, and chances are that many people think that domain names are all the same. However, it is not so, and we will see that as we move along. A domain name is a memorable name that is associated to an IP address, such as the one that you see there, a number that is composed of various octets, such as the one that you see there, 123.456.789.12. However, hardly anyone will remember a number like that. Consequently, it is so much easier to remember your name.pr or your name.com or your name.ca. It is the way in which we can connect. So you contract with a web hosting company, and once you design your web page, then you can associate that address with a domain name and that IP, and that is done at the web hosting service. So that is how we can get to the different locations that we're looking for. It's so much easier to remember that way. Next slide, please. And as I mentioned earlier, there are different types of domain names. There are 3 types of domain names, and there are GTLDs. The G stands for generic top-level domain, CCTLDs, which are country code top-level domains, and sponsored top-level domains. As Glenn mentioned earlier, both Alyssa and I are members of the country code community. And so let's move on to the next slide, please. Let's take a look at this. If we're speaking about the generic top-level domains, there are different kinds, even within the generic top-level domain. So as you can see, every single domain name has a purpose. Is addressing a particular interest of a particular community, geographic group, geographic region, a particular ethnic group, or a particular professional interest. Let's take a quick look. Look at the classic top-level domains. That is the .com, .net, .org, .biz. We all know those. But then after a while, people began to ask for more specific top-level domains, generic top-level domains that would identify what they do. And that was called the new generic top-level domains, or the new NGTLDs. As you can see, there's a whole bunch of them, more than 1,300 of them, and many more coming down the pipeline. You will see that some of them are .online, .shop, .legal, .echo. There is a myriad of domain names that identify different interests, professions, and tendencies of all sorts of kinds. But there's also the introduction of generic internationalized domain names. We call those IDNs. So it's GIDNs. And as you can see, if you take a look at the red dice, you will see a number of characters in the Cyrillic language. And that stands for that will stand for a particular either website, business, store in Japanese, such as the one in the lilac color dice, and so on. Similar to the new GTLDs, except that this time we're using a number of characters that are relevant to a particular language. That way, enabling the capacity of those people who speak that language to find content in their own language and to produce content in that language for that particular community. Next, please. Now, let's take a look at the sponsored TLDs. The sponsored TLDs are very interesting. There are about 14 of them at this point. And you will find, similar to the new GTLDs that the sponsored top-level domains also address a particular need, which is identifying a particular geographical region. Let's take a look at that CAT, which stands for Catalonia, or that Asia, which are meant to identify individuals from those particular regions. Some of these are restricted. For example, that CAT requires that all of their websites, the content of those websites must be in the Catalonian language. If we take a look at others, you will find that are associated by professional interest. Look at that EDU, stands for education, and is normally used for universities who have 4-year programs, from 4-year programs all the way to doctorate, and you will find them normally in the US, as well as in some parts of Europe are beginning to adopt that EDU. Take .gov, for example. Any domain name that ends in a .gov domain, extension, it is representative of a governmental agency, department, or a particular association that is related, service that is related to the government. And there are others like that jobs, that XXX, which is the domain name that is used to agglutinate those websites that are related to the porno industry. That co-op, which is one that is meant for cooperatives and mostly used for those financial institutions that are created to provide services to a particular community. Next, please. Now, here we come. And if we take a quick look at this, these are the ccTLDs, of which .PR, .ca, and so many others, as you can see there, .es for Spain, .mx for Mexico, .ca for Canada, .pr for Puerto Rico, on and on and on. There is a great deal of us, and we have been associating themselves even before ICANN existed, which is quite an accomplishment. As you can see, ccTLDs, pretty much like new GTLDs, are divided in two kinds. One are the ASCII codes. ASCII stands for the American Standard for Information Interchange. And ASCII, all it means is that it uses the numbers from 0 to 9 and the letters from A to Z in the Latin script. However, there are other ccTLDs that have been created in various languages. For example, the red dice, you can see there, once again, that is written in Cyrillic language, and it stands for Russia. Others stand for India, China, Thailand, and so on. The idea is that, once again, you want to enable and invite those individuals that normally are part of the internet but do not speak the English language. And it's so much easier for them to find content, relevant content to them, for the culture, in their own language. And that way they can interact, participate, and take advantage of the internet in the way that it was meant. Next, please. Now let's take a quick look at this. This is the map of the current IDN ccTLDs that exist. As you can see, there is a number of them in Africa, such as Morocco and Malawi, and so many others within there. India has a great number of IDN ccTLDs that have been developed in order to integrate these individuals. Let's keep in mind that by 2025, we're expecting an additional 1 billion users, 1 billion internet users. This is no simple fit, and we have to provide a path for these individuals to engage in the internet express themselves in their own languages, find content in their own languages, and be able to take advantage of the various services and facilities that are available in those particular languages. Imagine all of the information and all of the people that we can reach in these times of pandemia, in which you can spread information in so many different languages, because now the internet is set up to be able to handle this type of characters that in the past were not available. If you would like to find more information about that, take a quick look at the link below, and you will find further information on that. Next slide, please. This is the ccTLD world as we know it. And you can see that each one of these ccTLDs are identified by a two-letter code. Similarly, they are two-letter codes, as you previously saw, in various languages for each one of these particular regions. Next, please. So let me tell you how does ccTLDs associate and participate within the ICANN ecosystem. There is an association, an organization called the Country Code Name Supporting Organization. And this organization agglutinates 172 members out of the 198 countries around the world. We continue to add many more members coming up down the pipeline. Each one of them, as you can see, come from different areas. Let's take a quick look at North America. North America is comprised of 6 ccTLDs. There is Canada, that's CA. There is the United States, that US. Then there is Puerto Rico, that PR. The US Virgin Islands, that VI. But there is also that AS for the American Samoas, and also the one for, there is one more, and escapes my mind. When I'll remember, I'll remind you. But there are 6 of them, and they're all participants of the cCNSO. There are 28 current ccTLD members participating from the Latin American and Caribbean region out of 47 of them. And there are 38 ccTLDs from the African region out of 58. So we still have some work to do. Europe is mostly present in the cCNSO, as well as Asia Pacific. This is how we interact. We interact among ourselves, we cooperate among ourselves, and we work together in order to provide a voice to the ccTLDs and to the rest of the ecosystem. Next slide, please. The cCNSO was created in around 2003, and it is a structure within, it is an organization within the ICANN structure for and by ccTLD managers. It provides a platform to nurture consensus, technical cooperation, and skill building among ccTLDs. In other words, this is a platform that was created in order to help each other out, as I mentioned earlier, and to be able to facilitate how other ccTLDs can do a better job each time, and to be able to comply with the different changes in technology. We are also responsible for developing and recommending global policies to the ICANN board for a limited set of issues relating to ccTLDs. For example, internationalized domain names, ccTLDs. Now, one thing that I would like to point out at this moment is that domain names are this 2-letter code for the country codes are not given by ICANN. Instead, this 2-letter code has been adopted from the ISO 3166-1, and it is an alpha 2 code that assigns 2 letters for each domain name. So something else that we have to look out for when we discuss domain names, and one of those recommending policies that the cCNSO makes, imagine if we were to use the alpha 3 code, which is a 3-letter code that you will find in the Olympics. And you will find that your country is identified by a 3-letter code. And for example, if we were to use that to identify countries, Comoros, the island of Comoros, would be .com. And obviously, we would have a tremendous conflict there. So these are the type of arguments and observations that we bring up to the global and to the global community, as well as to the ICANN board. Next, please. The cCNSO Council is a team that is made up of 18 individuals. These 18 individuals are comprised of 3 members from each of the 5 regions that were previously mentioned, 3 from Africa, 3 from Asia Pacific, 3 from Europe, 3 from Latin America and the Caribbean, and 3 from North America. I am one of those 3 councils from North America, as Glenn mentioned earlier. And we also received 3 counselors from the nominating committee, which provides an outside look and gives fresh eyes to many of the policies that we're working on. These 18 counselors are led by a leadership team that is comprised of a chair and 2 vice chairs. The current chair is Katrina Sataki, and the 2 vice chairs are Alejandra Reynoso from the Latin America and myself from the North American region. Next slide, please. Now, let's take a quick look at how the cCNSO participates within the ICANN structure. As you can see, we have different representatives from different groups, but not all of them have the ability to vote and to bring representatives there. Let's take a look. You have in the orange circle is the president and CEO of ICANN. Then you have the generic name supporting organization, the GNSO, which was represented by Keith last time that he spoke in this forum. Then you also have the address supporting organization, who are the ones that agglutinate all of the different registries that manage all of the IP addresses, the RIRs. And in addition to that, such as ARIN, RIPE, APNIC, and LACNIC, and so on. And then you have the country code name supporting organization identified by the red circle and the arrow. And you will see that we have a participation where we have 2 chairs there. The GNSO has 2 chairs. The address supporting organization has 2 chairs. The president of ICANN has a chair as well at large. And then you have in the brownish and darker colors, you will find that you have some advisory groups such as the GAC, IETF, RSAC, SAC, and so on. And they are advisories committees that are also providing a tremendous and extremely valuable service to the community. Next slide, please. So let me tell you a little bit about Puerto Rico top-level domain. We were founded in 1989. We were delegated in 1989, and we began operations at that time. Then by 1994, we began to register domain names for the government very early on. By 2003, we developed the first portal that allowed our customers to register domain names online and to be able to pay for them online, facilitating registrations that way. By 2005, we were the first country code top-level domain in the Americas, from North America to the Patagonia, to sign its root with DNSSEC. Even before ICANN, even before .com, we already had DNSSEC. We were only second to Sweden, who were the first one in the world to register, to sign its root with DNSSEC. In 2007, we hosted the first ICANN meeting in the Caribbean. And it was an amazing opportunity because it was the one way that we were able to bring so many of our colleagues around the Latin American region, because it was so much easier and accessible for them to come to Puerto Rico and begin to participate. We had fantastic participants there, of which some of them are currently leaders in the ICANN organization. Moreover, in 2018, right after Maria, the Hurricane Maria, we were able to celebrate the second ICANN meeting, ICANN 61, in which we were able to bring a tremendous number of participants. And we're so looking forward now for 2022 to celebrate the next face-to-face meeting. Crossing fingers, we're not sure if we will be ready by then, but I sure hope so, that we will be able to get together again in Puerto Rico by March of 2022. Next slide, please. Let me tell you a little bit about DNSSEC and what is going on with this. Why is this important? Well, as I mentioned to you earlier, DNSSEC is a protocol that protects individuals from being spoofed and from phishing. DNSSEC is a protocol that prevents malactors from hijacking a website and redirecting it to another malicious place where they're collecting usernames and passwords that later on can be used to commit fraud or to steal your identification, to steal your goods. The DNSSEC is one way in which it can use a way to authoritatively identify who is it that you're speaking to. When you do not have DNSSEC, it is relatively easy and open to a risk that a malactor can redirect a website such your bank and capture your information and capture your username and password and use that information to steal your money, to change information, to sit on your website and capture emails, and to act as if it were you. So it is critical that we ensure that DNSSEC is used and implemented in every website and that is available by every CCTLD and available by every one of the institutions that you normally visit, such as your bank, your hospital, your insurance, travel agencies, and so on. So you need to be aware whether or not the websites that you're visiting are using DNSSEC or not. And this is critical. Let me share with you a little bit of the information that I found in one of the latest research that I accomplished not too long ago. Next slide, please. Next slide, please. Thank you. So I studied the 47 CCTLDs of the Latin American region. I invited the 47 CCTLDs of the Latin American region, Latin American and Caribbean region to participate in this study. Of them, 26 of them have DNSSEC. 24 CCTLDs were the number of participants that took place in this research, and 12 of them have DNSSEC and 12 of them did not. Next slide, please. So, what were the findings? There is lack of budget to support at organizational and hardware level, because it's not only about having hardware, but it's also having the people that can help you out with that. And misconfigurations that impede the implementation of DNSSEC. We need to have better workshops to help out these individuals. Workshops are needed to provide all sorts of materials such that decision makers can understand the importance and began to implement the DNSSEC at government, banking, and commercial institutions. Reputation is a major driver of technology adoption. You would not want to visit or do business in a website where your information could be easily obtained. And so you need to make sure that each one of the websites that you visit has the DNSSEC. Next slide, please. So what are some of the recommendations? Develop workshops to increase institutional support and reduce DNSSEC implementation difficulty. Develop workshops to explain to ccTLD operators the cost, minimum number of personnel needed, training and infrastructure involved in the implementation of the maintenance of DNSSEC. Develop interfaces to reduce the workshop of corporate clients so signing with the ccTLD. It's not enough for a ccTLD to adopt DNSSEC. It is also important that your local bank, your local hospital, the church, a travel agent, insurance company, they all adopt and sign their zones with the DNSSEC. Moreover, we also need to develop interfaces to reduce the workload involved from the client side. And in addition to that, we need to develop and integrate a warning system. If you notice, when you go to a website that does not have a security certificate, an SSL certificate, you will find that the browser identifies that and it lets you know, beware, this is not a safe site. You will go on at your own risk. However, a website that does not have DNSSEC, it doesn't have that kind of warning system. We should find ways to implement a warning system that will allow users to know whether DNSSEC is implemented or not. Next slide, please. If you would like to read more about this research, and there are many more things that were not discussed about this research in this presentation, you can find it at the green link that you find there. You can also contact me via email at pablo@rodriguez.pr. Next slide, please. I thank you very much for this opportunity. It's been a great honor and a pleasure, and I remain available to you should you have further questions or comments. Thank you very much.
All right.
Yeah, go ahead, Glenn.
Thank you. I have a question, and I encourage other people to jump in with their questions as well. You know, and I realize you're trying to reach out and provide the seminars and education, but it strikes me that you would think the insurance companies would, because of liability and litigation, they would force these folks to be compliant. Is that not the case, or maybe I got it wrong?
No, not at all. You are not wrong. North America is well ahead of its game, as well as Europe. However, in regions such as Latin America and Africa, the adoption of DNSSEC is very slow. And there are many companies, major companies, will purchase their domain names and their services in North America and or Europe. Consequently, they will have those services. But for those companies that are located in Latin America and the Caribbean and that are located in Africa, they need to make sure that if they are not purchasing those services from these other companies, they better find ways to adopt and implement the DNSSEC sooner rather than later. So yes, it is important that you need to make sure. Something that I also would like to bring to the attention of people is that it's not easily found whether a website has the DNSSEC or not. So it's not like you can find if a website has a certificate of security and SSL, you will see in the URL that says HTTPS. So immediately you know that it has a digital certificate of security. However, with DNSSEC, we have no signs of knowing that. So it is important that we as end users know that information, because it will make a huge difference whether or not you're at risk.
Pablo, this is Eduardo. I do have a question also, and it has to do with the country code cCNSO within ICANN. I don't know if you went over it, but you know that the GNSO, the Genetic Name Service Organization within ICANN, are the organization that develop policy for the general, the generic top-level domains. But in the case of the country codes, which are really independent nations, does the CNSSO develop policy at all? And are these cCNSOs, all the country codes, do they supposed to follow this policy? I mean, how do you deal with that within ICANN?
Thank you for the question, Eduardo. That is a very good question. In fact, if you go back a few slides to the section of the cCNSO, you will see that there you go. Now, go back a little bit. One more. Stop.
No.
One more. One more. No, you're going backwards, the other way.
Okay, I'm sorry.
There you go.
That one.
That's the one. So you will see the last bullet says responsible for developing and recommending global policies to the ICANN board for a limited set of issues. And so the cCNSO develops policies pretty much like the retirement of ccTLDs, PDP-3. And you will find that that is a huge policy development process that has to do with the retirement of certain domain names, certain ccTLDs that are no longer in existence. For example, there used to be a ccTLD for the Soviet Union, that SU, which is no longer being used because now there is the Federation, the Russian Federation, which is RU. But there were also other countries that are no longer in existence, or their names have changed. For example, Yugoslavia. Yugoslavia changed its name from Yugoslavia to the Republic of Macedonia. So what do we do with that particular domain name? What do we do with domain names like the Soviet Union? We need to have a process to be able to take those domain names back. But what happens to all the users that had websites under those ccTLDs? So there is a process that we're working on, and it's called the PDP-3. In addition to that, there is also a PDP-4 that is coming along that has to do with the IDN ccTLDs. Currently, under the bylaws of ICANN, IDN ccTLDs are not members of the cCNSO. And all they're doing normally is the same ccTLD with the two letters is using now their respective languages to represent their country in those particular characters. And so the PDP-4 is working on that. Consequently, cCNSO members are bound by this policy development process. And it is in the cCNSO where we adopt its best practices, as it is mentioned there. We find that consensus, that technical practice, that's best practices and skill building among ccTLDs. So all of that is taking place within the cCNSO. And yes, they are bound by these different policy development processes, which are also worked in conjunction with the GNSO. In other words, both the cCNSO and the GNSO, we interact among ourselves to ensure that we are developing policies that make sense both for the GNSO and the cCNSO.
I do have a question by Alyssa. It says, we are presently working on a policy about ccTLD retirement. When a
PDP-3.
Excuse me?
That is called PDP-3.
Oh, okay. But the question is, when a territory/nation ceases to exist, like the example that you gave, what happened to their ccTLD, to that ccTLD that got retired? I guess that's the question.
Correct. Yes, the ccTLD gets retired, but how is it retired is the process that it's being currently worked on.
Yeah, but I think the question is what happened to the ccTLD that is retired, to those two letters? Can they be used, reused, or just they disappear?
No, those two letters remain retired, and again, that has been worked on. But what happens is that ICANN is not in the business of identifying countries or defining or deciding who is a country or territory. So if in the ISO 3166-1 Alpha 2, which is the two-letter codes, that country no longer exists, consequently, those two letters are not there anymore, then it cannot be used.
Alyssa says it's not a question for Pablo. That's the question we are trying to answer in the PDP-3. Sorry that you were correct, Pablo. Anyhow, I have another one by Olivier Kwamani. Hopefully I'm pronouncing the name correctly. What's happening with the Estawini now, for example? I guess Estawini is a state, a nation, or city. I'm not sure. Have you heard?
I didn't catch the question. Can you repeat it, please?
The question again is Olivier Kwame asking what's happening with the Estawini now, for example. Estawini, I believe, is a nation, or you know.
I am not familiar with that. However, if you send me an email to both either pablo@nic.pr or pablo@rodriguez.pr, which is in the last slide here, I'll be happy to look for further information, but I am not familiar with that particular agreement.
Okay, but in any case, when I think you answered the question before, that once the ccTLD retires, that's it. It stays retired. It's not.
Yeah, this is something that is decided in the United Nations. So the United Nations decides and defines who is a country or a territory.
Okay.
So they are the ones that decide in this code of countries and territories. These are the two-letter codes assigned to that particular country or territory. So at that moment, when that changes, we have to make an update.
Okay. So Glenn, are there any other questions?
Actually, it's interesting because Alyssa is jumping in on the answers as well. I was asking the question because she made comment about what happens with country codes that have been, I guess, went into retirement, and she just provided information in the chat as well. So, but that's it for me. I'll turn it back to you, Eduardo.
Yes, there is a question by David Mood. Again, my apologies if I'm pronouncing this wrong. How do countries formally allow their territory code to be used more like GTLDs? And he's, just like it, for example.
Thank you, David. That is an amazing question. So normally we call those boutique domain names because for some reason, usually as a result of the English language, those two letters are recognized as something else. Take, for example, I see in the chat, someone was mentioning about that TV. So if we mention that two-letter code is what defines a country code, then what is that TV? Is it television? No, it's the country of Tuvalu. And as you know, that CL, which is the country of Colombia, is used as company as a result of historical issues, pretty much similar to what England used to use with that UK. They used to have that code, that UK, as a form of expressing this is commercial under UK, since .com was taken as one of the generic top-level domains. So each country code found ways to define what a website is for. Is this extension defined for commerce and so on? However, some of the two-letter codes are being used because it means something to somebody else. For example, the Federation, the Federated Nation of Micronesia has that FM. And so many radio stations use that FM for modulated frequency, right? Or frequency modulated. And you have the country of Armenia has that AM. So some people can use that to talk about either radios or to refer to morning activities. Moreover, Puerto Rico is no exception. Many people, and we have many customers that purchase that PR, not because they are websites that are related either to Puerto Rico or to businesses that are found in Puerto Rico, but rather because in the English language, that PR is used, or PR is used to refer to public relations. So it happens that users decide that that particular two-letter extension means something to them, and that is used in such ways that we have no control over that.
Okay, I don't see any more questions, Pablo. So I want to thank you for your time, and you're welcome to stay and hear the other presentation, and for giving so much a very interesting information. I'm pretty sure the people attending today will appreciate very much the input and explanation that you gave about ccTLDs and other things like related to the domain name system. So
thank you so much.
Thank you, Pablo. Thank you so much. So let me put myself in here. Thank you. And the next person, the next presentation. Well, let me move forward. Second. So I have to move this forward. Okay, so now we have Alyssa and talking about the internet infrastructure and the DNS. So Alyssa, you can go ahead and do your presentation. Thank you.
Thank you, Eduardo. So my name is Alyssa Moore, and I work on policy at the Canadian Internet Registration Authority. Can everyone hear me okay?
Yes, we can hear you okay.
Okay. I work on policy at CIRA, and we're the country code for Canada. We're .ca. And Pablo just did an excellent job of explaining the ccTLD world. We're all a little bit different in how we operate, as he just explained, with reference to how some folks use certain ccTLDs as generics. And we're all creatures of the legal frameworks within our respective jurisdictions. So .ca being in Canada and having our user base in Canada, our membership early in CIRA's development decided that .ca is to be used for and by Canadians. And so we are what's known as a closed ccTLD, and that we have requirements that registrants must meet. And in our case, you have to have a Canadian presence. So be a Canadian citizen or permanent resident or have a business presence in Canada, or be a member of the royal family. Members of the royal family can also own .CAs. So we're a nonprofit organization. Our board is elected and we're run on a not-for-profit basis, meaning we give back to the internet community in Canada through a granting program from revenues that are earned on our various products. And today I was intrigued to be invited to talk about internet infrastructure, especially because in many circles, when people talk about internet infrastructure, they mean the physical cables or wires that connect your home to an internet service provider, or that connect you to the physical internet. But that's only a very small piece of the picture, and there are so many organizations, so many protocols and data centers and standards and different pieces that make up the internet and the infrastructure that underpins it. Next slide, please.
It's coming.
Thanks. So here's a graphic that's pretty complex and one that very few can fully understand. And it's a visualization that comes up when you type in internet into Wikipedia. And it's a visualization produced by the Opti project. And it's meant to show just a few of the routing paths in one very small corner of the internet. And that's to say the series of hops or paths between routers on independent autonomous systems. So the theoretical and practical paths that packets take from one host to another, meaning one computer to another. And the complexity of this just also shows the enormous amount of effort and potential and interdependence required to keep the internet running. I think the last time I checked, it was either earlier this year, or maybe, yeah, it wasn't 2021 yet, but there were 92,000 autonomous systems connected to the internet, with an autonomous system being one organization that operates its own network that is then connected to the physical internet, and connected via what's known as Border Gateway Protocol. And that number has been growing each year, year over year, and will continue to grow as more and more networks are connected to the internet. And without an international ongoing effort to keep it all running in both the technical and policy worlds of the internet, it would fracture, it would cease to work. And there's all sorts of different policy fora and bodies in the different layers of the internet that helps it all to work together. And no one person understands it all, not all of the technology, not all of the policy, and certainly not all of the governance. Next slide, please. So when most people think of the internet, the major platforms that dominate our social and work lives will come to mind. These logos up at the top right used to be in the news for revolutionizing our lives and being the darlings of the stock market, but they're also the ones who more recently are frequently in the news for butting up against our notions of what is right and wrong with modern civilization, because they're so intrinsically tied to our daily lives, especially in a pandemic, be it privacy concerns associated with these or predatory market practices, or just for being addictive technologies. But as big and dominant as these companies are, they aren't the whole internet. They're nowhere near the whole internet. They're just the tip of the iceberg. So they're just a couple of examples of a few applications that run on top of the layers underpinning them in terms of internet infrastructure. Next slide, please. So when we visit a website or use a service, we are at layer 7 for the most part, and that's where those logos are sitting above that red line. The layers underneath that are where CIRA spends most of our time working and thinking about policy, and certainly where our technologists are working on our little piece of internet infrastructure. There's a lot of companies and many folks who are never really talked about or much less known for making the internet as an integrated technology built on thousands of standards and protocols, making that operate. And the internet is not just one technology, it's not one thing, it's layers of different technologies running together to connect the entire globe. Some of it is quite old. There are pieces of the internet that have not changed in years or even decades, and the overall architecture is distributed. So the whole internet is whatever parts are running at any given time. Next slide, please. So who controls all of those components below the tip of the iceberg? It's not one organization, it's a shared responsibility, and it's distributed between hundreds of organizations coordinating and performing different roles. So this 7-layer architecture is a conceptual model for understanding the architecture of not just the internet, but any kind of network. But it's very helpful for conceptualizing the internet. And as the name implies, the internet is a network of interconnected networks, and it's constructed like one giant metacomputer with a standard model for construction. So when you're working with a standard model, the different players know their respective roles and how to operate within them to interoperate with other pieces of the architecture. So this OSI model is really great at demonstrating the different layers. And I also think it's a good model for understanding the different policy pieces associated with the internet. There's a whole host of entities involved in setting the standards and protocols, and a whole host of entities responsible for the different policy issues associated with each of those layers of infrastructure. So for example, if we begin at the bottom with layer 1, the physical protocols and standards, that's layer 1 of the internet, and or layer 1 of a network. And this is concerned with the actual physical infrastructure that I was talking about at the beginning of this presentation, the wires into your home. So when it comes to a fiber optic, each pulse of light on and off is representative of a 1 or a 0. Or in coaxial cable, the current running through it, the peak and the valley of the current is representative of a 1 or a 0. And when it comes to wireless transmission of data, the peak or the valley of a wireless wave, a wireless signal, is representative of a 1 or a 0. And that's all physical elements of the transmission of data over a network. So that particular layer of infrastructure, when it comes to policy and standard setting, is, I think, most closely associated with an organization like the International Telecommunications Union, which is the oldest international organization on the planet, and has to do with telecommunications infrastructure and its global interoperation. And then we get up into the 3, 4, and 5 layers, and that's the logical protocols and standards where we spend most of our time in the DNS industry, the domain name industry, because the DNS is most closely associated with layers 3 and 4. So logical addressing and domain names, IP addresses kind of live in this area, and this is where ICANN and the regional internet registries for internet numbers, that their policy work goes on. And then when we get higher up into 6 and 7, this is more closely related to the tip of the iceberg. So what a user is interacting with when they're using their web browser, using an application or service on the internet. And then once you get into that layer, what people are interacting with service-wise or content-wise, then you're into the purview largely of different jurisdictions, regular laws around privacy and speech and any kind of content that you would see online. And that's where a lot of the very high profile conflicts and discussions about internet infrastructure are happening right now. But those conversations also are increasingly digging deeper into this 7-layer stack. It's not just what's happening at the application layer. So thinking about Parler or Parler, this very controversial Twitter-like app that has been in the news lately. Their infrastructure services, which would be provided by companies further down in this stack, their bare metal servers that they were operating their service off of, decided not to do business with this particular application because of concerns about their content moderation practices. And we're seeing some policy actions being taken further down in the stack rather than just up at this layer 7 application layer place. So where does CIRA and the DNS fit into all of this? And Pablo did a really great job of talking through this, how domain names are translated into IP addresses. And this is the graphic that I like to use. So following the line from making your query from your laptop or your phone, and you're asking this hierarchical system to look up hello.ca. And then there's a hierarchical series of servers who are known as resolvers that will respond to that query in a predictable fashion. Next slide, please. And how does that translate into infrastructure? Well, those resolvers are ultimately computers, and those are infrastructure, and they need to be physically located in strategic places. So as much as the internet is very logical and abstract, it still does have a very physical element to it. And if I am in Australia and I am querying a .ca domain, I don't want that query to have to travel all the way from Australia to Canada physically over submarine cables in order to get its answer. Hold on, I gotta let my cat into my room. She's meowing quite loudly here. So what we do as resolver operators or ccTLD operators is we try and locate that infrastructure in strategic places so that query isn't having to travel all the way around the world in order to get to the person that's making that query. We'd rather have them query a database or a server that contains that database that's much closer to home, and that will get them a much faster result because that query does not have to travel around the world. And this is known as Anycast, and this is how CIRA has architected its DNS in order to best respond to users' queries. Next slide, please. Another major element of internet infrastructure that is important to us in the DNS and certainly at CIRA are internet exchange points. And this is a physical space where internet service providers and other types of networks, including content delivery networks like Google or Akamai or Cloudflare or Netflix, it's where they physically exchange traffic directly with each other. So where they're essentially running cross-connect wires to exchange traffic with each other directly, which is this other part of this physical presence of the internet. And these aren't massive data centers. Often internet exchange points are just a couple of racks within another data center. So what this allows networks to do is to locate important content much closer to the end user and get closer to what we call the edge. So putting a Netflix cache, it's known as a cache, C-A-C-H-E, within the local ISP of a user, the closer to a major metro area. So say in Toronto, having a Netflix cache with the entire library of Netflix content, which then the local ISPs in Toronto link into physically, is going to get you a much better performing experience for that content delivery for a user in the Toronto area. Exactly, I'm seeing Olivia in the comments say it's to localize the local traffic, and that's absolutely right. We want to minimize instances of traffic having to travel all the way around the world when it doesn't need to. And so our goal at CIRA in supporting internet exchange points in Canada is to get more traffic to stay within Canada and to increase the presence of that important content caching and of local exchanges, because it increases resilience and performance of internet services. And in Canada, we're in a unique situation because we are, just north of a very big superpower to the south of us, and there are many networks and exchange points just south of our border. And the idea with our organization supporting internet exchange points in Canada is to keep as much of that traffic north of the border as possible for resilience reasons. And I think I'm going to end it there. I'm seeing a couple questions popping up in the chat. So David is saying, does policy around the use of a country code change how resolvers cache domain name addresses? For example, .ca for Canadian residents, but .co is a boutique address. So maybe the lookups are distributed differently. Yeah, so there's different TLD operators, managers for each of the different TLDs. So yes, they would be distributed differently. We make decisions at CIRA about how we distribute .ca through infrastructure. We also have a robust system of infrastructure that we've built that we provide to other TLDs. If they would like to cache their services on our infrastructure, they can. But ultimately, the operator for .co would be responsible for determining how to structure their presence of resolvers around the world. So that's kind of one of the major roles of different ccTLD operators, which is to determine how to architect that infrastructure to best service its users. And so when choosing where to put or which domain name to use, something a registrant might take into consideration is how robust is the backend infrastructure for this top-level domain operator. Is it someone with a global presence, or is it someone who only has a few resolvers on one continent? and the robustness of that infrastructure will determine how quickly someone is able to access that domain name. It might tack on a couple of seconds if the infrastructure is not suitable. I'm just scrolling through any other questions.
I do not see any other questions. Glenn, do you have any questions? Well, I do have one question, Alyssa. Is the .ca restricted just to Canadians, or can someone from outside buy a domain there?
Yes, so .ca is a closed ccTLD, meaning that it is restricted for users with a Canadian presence. So you don't necessarily have to be Canadian, but you need to have a Canadian presence and that you are operating a business here, are a permanent resident here, or have some tangible link to Canada that's laid out in our policies. So .ca can't be used like a .co or a .tv is.
Okay, thank you.
Yeah.
Are there any other questions, Glenn?
Okay, sorry, it took me a minute to unmute. Thank you. I just need to emphasize that my experience with CIRA, I was on the NomCom for CIRA a number of years. Great experience, great people that work at CIRA. They have a fantastic new office that overlooks the football field, which is a great plus as well. But one of the things I need to shout out, CIRA did an incredible advertising campaign lately, which is completely antithesis to the typical passive or gentle Canadian. So it's absolutely humorous. So if any of you maybe some of those ads are on your website, Alyssa, or they can look it up. But they're quite eye-catching. So it really a departure from the normal fit. But I think it's all done in good humor.
Yes, absolutely. So our recent ad campaign has to do with you have to be Canadian to get it, right? To get a .ca, and so the joke is you have to be Canadian to get it, or some are related to Mounties, which is a police force that dresses in quite interesting costume, or to park rangers, and it's all very Canadiana.
And I'll do another shout out. You've been very active in your team with the Canadian IGF as well. And prior to the Canadian IGF, you used to run your own Canadian internet event as well in Ottawa mainly. So again, any of the Canadians on the line here, the AGM is publicly available. If you want to run for the CIRA board, it's an open process as long as you're a CIRA member. So this is a real contribution. So this is fantastic. I appreciate your time, and I'm going to turn it back over to Eduardo.
Thank you, Glenn. I don't see any more questions. I saw a comment by Pablo that .pr is available. It's not a closed ccTLD. It's open to anyone that wants to have one. But with this and not having more questions, I want to thank Alyssa again for her time and the information that she has provided us and all of us on DNS and the DNS infrastructure and give us a perspective of how they do it in Canada. So with that in mind, I don't know if you have other closing remarks, Glenn, before closing this.
No, I'm great. Thank you very much. And again, there'll be a little time for us to convert this, but the actual file will be up on the Moodle site fairly quickly. And please reach out to either of the speakers today if you have any questions. And again, thank you all for joining today, and we'll see you next week on the development module.
Okay, Glenn, do they have the link to do the mini survey after this?
Yes, I posted it a few times. I can look for it again. I have to go back to the chat. So I've been trying to post material that on the cCNSO. I should mention I'm on the ICANN NomCom, so it is an open process to. So bear in mind, I gave you the link as well. to the CCNSO as well as the ICANN NOMCOM. So there is one position for CCNSO this year. So bear that in mind. And I'll try to dig to the problem why the ebook ended up being a user problem. There seems to be a software glitch. I've contacted the people about that. I used to never have that problem, but we'll get to the resolution of this, and I'll be posting the slideshow as well. So again, thank you all for joining today.
Okay, thank you so much. With this, this meeting is adjourned. Thank you everyone for attending today's presentation. Bye.
Good evening, good afternoon, good morning. Please may I have the next